Okay. Okay, that's calc homework. Okay, now, yeah, let's go ahead and roll the die. It can't be the same person. It has to be somebody who's never rolled it.
I didn't do the homework. I'll roll
Who's
it.
never rolled it?
I'll roll it even though I didn't.
I never rolled it.
You haven't rolled yet?
Oh, you call in? I swear to God.
Only the first time I practiced.
Oh, practice.
Five.
No check.
No, no.
No! I need that check.
So, no check, but we will go over any questions you have, so go ahead and take it out.
I hope you enjoy it.
What page was it on? 89.
89 to 92. 81, 92, not 82.
Okay, any questions over? Did you check your answers in the back?
Yes. 60. Actually, 55. 9.
Okay, wait, 60,
55.
55.
55 screws.
Storage tanks.
Yes. 9 and 27.
What on else? I'll do all the homework.
She says mistakes. I really don't know. She says.
Okay, the Research and Development Department of an automobile manufacturer has determined that when a driver is required to stop quickly to avoid an accident, the distance in feet the car travels during the driver's reaction time is given by R of X equals 3/4 X. Yeah. Where X is the speed of the car in miles per hour.
I'm getting to.
Okay. Uh-huh, thank you. The distance in feet traveled while the driver is braking is given by V of X equals 1/15 X squared. Find the function that represents the total stopping distance T. Graph the functions R, B, and T on the same set of coordinate axes for 0 to 60.
Go fish shot.
Yeah, please. Okay, so total reaction time T equals what?
R of X plus ZB of X.
Reaction time plus braking time. Graph the functions R, B, and T on the same set of coordinate axes. I only need the first quadrant. Why?
Positive.
Everything has to be positive, right? My
Yes.
reaction time, my braking time, everything has to be positive, so I don't have to worry about. Oh wait, for X is 0 to 60, I did T. Thank you. Okay, 3/4 X, that one's the easier one to graph. So, but these are counting by ones. I hope that's enough. I don't think they have to count by anything bigger. Shouldn't take you that long to stop your car. So if I go up 3 and run 4, there's R of X. 1/15 X squared is parabola, it passes through 0, 0. Let's see, if I plug in 5 squared is 25, 25 over 15 reduces to 5/3. So 5, 1, and 2/3. So the parabola, these got to intersect somewhere, I just don't know where. Okay. And then, that's really bad. Okay. And then these two together, whew, let's plug in 5 again. T of 5, 3/4 times 5 plus 1/15, 5 squared. 3/4. This is 15/4 plus, we just did this one, it was 5 over 3 times 3 times 3 times 4 times 4 equals 45 over 15 plus 5, 25 over 15, that's 70 over 15, reduces by 5, here's another one's 14 over 3, 3/14 is approximately 4 and 2/3. 4 and 2/3. So all I did was plug 5 in and did a bunch of mental math. So I know 0, 0 is on the graph of my parabola, my time it takes to break, and the point 5, 4 and 2/3. Ooh, it really takes a sharp turn. Must be way up there. There, that's T. Graph the functions. Okay, yeah, that's all we had to do. You said number
9 and 27.
Okay, number 9, the directions read, find f plus g, f minus g, f times g, and f divided by g. Do I have to do all of those?
Just do multiplying and dividing.
You could leave it like that if you wanted, or you could distribute. If you chose to distribute, it would look like this. So either answer is correct. I'd accept either one. Personally, I would do the one that required the least amount of work, so I would just stop right there. F over g, f is x squared plus 6 over the square root of 1 minus x. We could rationalize the denominator. If you didn't, where was my thought process going with that? Don't know. Okay, because it's has the denominator with the variable in it, and we have the square root function, we have to find the domain. So we know, if we're looking at our original function, before we did any other simplifying, we know x has to be what?
Not equal to 0.
It can equal, yeah, it can equal 0. What else? Well, the whole denominator. Well, okay, we know this can't equal 0.
Yeah.
What do we know about this? Bless you.
It can't be negative.
Right, so what inequality could I write? We know that this has to be,
Greater than whole.
right?
Yeah.
Yep.
This quantity can't be negative. Isn't that what this says? Okay, so now if I subtract 1, divide by -1, I get x has to be less than or equal to 1. Is 0 in this range or in this domain? Is 0 less than or equal to 1?
Yes.
And, oh, but it can be 0 because we're not worried about that. What can't equal 0? But it doesn't, so we're good. Wait, where will it equal 0? When x equals what?
1.
1, so all we have to do is smear that away.
Ooh. I see, okay.
Okay. I was gonna go with
I was a little
Okay.
confused.
I was like,
We got it.
okay.
Yeah?
But I understand.
Okay, so now what's my domain in interval notation, Maddie? I did this because I want you to practice it.
I know.
Yeah, okay, so what would my number line look like? Because we said, we talked and you said you liked the number line.
It's gotta go to the left.
It's gotta go to the left. And what's gonna be on the 1, an open dot or a solid dot?
An open dot.
Okay, now, how do I write that in interval notation? What number's way down here?
Negative infinity. 1.
Bracket or parenthesis?
Parentheses.
Does that help? You were the one that asked for the question. Does that help? Okay. Okay, 27.
I did not like 27.
I could not figure out 27 after, at the last part of 27 at least.
I didn't know what it meant by in the same sense or not. It's just the same graph.
Yeah,
I didn't,
That's what I did.
Why did it?
Never mind.
just like I did the T and R and the B just a second ago.
Alright, I could have just said on the same graph. Yeah.
Okay, well that's the parent function for the quadratic. The parent function for the quadratic passes through zero, zero, 1, 1, 2, 4. -1, -1, -2, 4. This is f. The linear function, g of x equals -2. They didn't give us any colored pencils, any colored markers this year. Probably too close together. -2 passes through 0, 0, and has a slope of -2. So down to run 1. Can you even see that? Up to
Yeah.
back 1. Passes through that point. If they intersect right there. And then f plus g. Is x squared minus 2x. Okay, so that's a quadratic. I can get my vertex. X coordinate of the vertex is opposite b over 2a. Opposite 2 is positive 2. 2 times 1 is 2, 1. So then if I plug 1 back in, that gives me the y coordinate of my vertex. 1 minus 2 is -1. So now we know our vertex is at 1, -1. Good so far?
Yep.
Is there any stretch or shrink on my parabola? No. There is no number greater than or less than 1 in front of the leading term. So there's no stretch or shrink. So I can plot this point, 1, -1, and use the trick that I showed you. Go up 1, over 1. That's a point on my graph. Go up 1, back 1. That's a point on my graph. So they all three pass through that origin. Then from there you go up 3. 1, 2, 3, over 1. Do the same thing over here. 1, 2, 3, back 1. And there's all three functions on the same graph. Okay, do you want to know another way you could do it?
Yeah.
Okay. Let's look at the point -2, 4. Oh no, I don't want to look at that point. Never mind. I want to look at a point where they both have the same x. So here, they all three have this x. So the f has -1, 1. G has -1, 2. So to get the y coordinate of f plus g, all I have to do is add these. 1 plus 2 is 3. Get it? The x coordinates are the same. If I'm adding my functions, f plus g, then all I have to do is add the y's. 1 plus 2 gives me 3. At the origin, we got 0, 0 for the black curve, 0, 0 for the orange curve. When I add the y values, I get 0. So that point is on the function. At x equals 1, we have 1, -2 for g, and for f, we have 1, 1. So they have the same x's. When I add their y's, I get 1 minus 2 is -1. So to graph it, you could just use the points without using your knowledge of what a quadratic is. Make sense? Okay. Any others?
36. Can you just do golf?
Golf. How'd you do on your domains when you checked your answers last night? Did we do okay? Just okay? Domain's challenging. Okay, g of f. So we're going to do g of the cubed root of x minus 5. Good so far?
Oh.
What happens when I cube a cubed root?
Equals out.
They cancel each other out. They're actually called, what kind of functions? It's actually going to be today's lesson. It begins with an I.
Irrational.
Nope.
Inverse.
Yes.
Ooh.
Inverse. So then we end up with x minus 5 plus 1 is x minus 4.
I thought it was x squared and it was giving me so much trouble.
Oh, you must have been looking at, kind of looking at
Yes.
in between the two. Yeah.
That's what got me so caught off on
No,
that.
you wouldn't be able to do that.
Yeah, I literally didn't know. I put like 2 question marks.
Yeah, you wouldn't have been able to do it. That would have just been your answer.
Yeah.
It would have been done.
That was messing me up on 9 because that's exactly what I did on the.
Oh, okay.
Yep.
Okay. Okay, any others? Okay, take out your notes. We're going to start section 1.9, inverse functions. And believe it or not, this is the end of the chapter.
That's not good.
Finally.
Give a test.
That means we have the test.
Yes. So tomorrow, we will probably, because I'm not gonna have half of you because you're gonna be on the field for Script Niles. Are you supposed to have good weather?
Yes.
Yeah.
Good.
It's supposed to be sunny, but it's gonna be 60 degrees.
Good. Oh, that's
Last
perfect.
year it was so sunny, I got sunburned.
Yeah.
Yeah, last year it was hot.
Remember that part?
I'll probably just pass out the chapter review. We'll take a test next week. We should take a quiz though. Maybe we'll do a quiz on Monday and then a unit test on Wednesday.
Well, if we do like Tuesday, Thursday, then we don't have to start anything new before we get off on Friday.
Yeah.
And nothing for the end of the 9 weeks, you know?
Maddie's so smart. We should-
Well, yeah, plus that little day review.
Why don't we do a quest?
No,
Nope.
I want a quest.
Plus similar points than quizzes and then
If we're taking a test too. Yeah, but we're also taking,
We are really behind.
Sorry.
We are really, really behind.
but then we're gonna start something new on Monday.
That's all right.
Or not Monday.
On Friday, on Thursday.
Yeah.
Yep. Okay, what do you remember about inverse functions? Tell me anything you remember.
They're the reciprocal.
Opposite.
Not reciprocal.
Opposition.
It's like kind of like opposite operation. Like
Yeah.
what undoes multiplication?
Division.
Division, those are inverse operations.
Yeah.
Yeah.
What undoes addition?
Subtraction.
Subtraction. What undoes x squared? Square root, right? So that's an easy, kind of an easy way to think about it. What do you remember about the notation?
No.
Not.
No. Nada.
Nobody?
If you said something, maybe I'll remember.
Give the first letter.
F.
Flip.
Second letter.
There's not.
What?
It's F of.
Oh, yeah.
What?
Oh,
I love when the light bulbs turn on. Oh.
I do remember that.
I do.
The notation for inverse looks like a power, but it's not. This reads F inverse of X.
I remember.
I remember that.
How do we get the inverse?
Well, there's something on your calculator.
I did work it out.
Yeah, there is something on my calculator that does do that for me.
There's a bunch of them actually.
Yeah, there's
I should write it down.
the only ones I remember using on the calculator was like sine.
You can't use this on the calculator.
No.
Oh. Someone said great.
How do I get the inverse of a function? Wasn't it on your summer packet?
Probably.
It's been kind of wrong. It's been a while. It's been 9 weeks.
I forgot at least half of algebra 2 already, so.
Oh.
Oh,
Oh, wait. Oh, okay. I might remember this.
oh, I hated this.
Sorry, didn't mean to
Okay.
switch x and y and solve for y.
Oh!
I
I
missed
do
like
remember
3
this.
days in a row last year and we were doing this and I just never got it.
Okay, so, one, you did this last year too. If f of x and g of x are inverse functions, let's forget that dot, then f of g of x equals x. And g of f of x equals x. Okay, are we good? Everybody still copying? Example 1. Given f of x equals 3x plus 2 find the inverse of f of x. Okay, so I told you switch x and y. There's no y. What do we do?
X f of x with y.
Yes. Remember, y is f of x. So we replace the f of x with y. Then we switch the x and the y. And solve.
Almost got a photo picture there.
Caught myself. So now you could say f inverse of x equals x minus 2 over 3. Okay, now we're going to verify. To verify, you show f of f inverse equals x and f inverse of f of x equals x. So basically, it's what I have written on the previous screen, but I've replaced g of x with f prime of x. That's all I've done. So it's still this. F of g of x has to equal x. If they're inverse functions, then this has to be true. So we're using our inverse. Okay, so we have to take and do first, we have to do f of x minus 2 over 3. If we don't get x, we did it wrong. So take f, that's 3x plus 2, and I have to plug in my x minus 2 over 3. So 3, x minus 2 over 3, plus 2. And I have to get x. What's the first thing I notice I can do?
Cancel out the 3's.
Cancel the 3's. Those turn into 1's. Now I have x minus 2 plus 2. The 2's cancel, and we get x. Yay! It makes us happy. Because if we don't get x, we know we made a mistake somewhere. Okay, now, notice it says and. Now we have to take our inverse, which is x minus 2 over 3, and plug x in. So we have to do f inverse of 3x plus 2. I'll let you do that one by yourself. We got it. Good? Questions? Not bad, right? Well, sometimes the weird functions get weird, but so far, not bad. Okay, now let's graph the inverse. Okay, so let's go back here for a second. So the notation for inverse is f inverse of x. How do we get the inverse? Switch x and y. Even if you had a table of values, to get the inverse, all you do is switch x and y. If I have a function, then I have to solve that function for y. But if I'm given a table, if I'm giving a list of linear, coordinate points, right? All we have to do is switch the x and the y, and that will give us the inverse. So remember that for graphing. It could come in handy. Graph the inverse function. The inverse of a function. The graph of f inverse of x is a reflection over the line y equals x. Are you cold, Addie?
Yeah.
You're freezing. If a b is on f of x, then b a is on f inverse. Oh, I wrote prime. We were doing derivatives last period. F inverse of x. Okay, good there? I have to change the screen because I won't have enough room there. Example 2. Graph f of x equals 2x minus 3 and f inverse of x equals 1/2 x plus 3. Show f inverse of x is the reflection of f of x over y equals x. Okay, how do you want to graph f of x equals 2x minus 3? I'll graph it any way you want. Options are make a table, use slope intercept form, and that's going to give you a point on the graph.
Slow.
Slope intercept?
Yeah. Slope brackets.
Okay, I'm going to do this one in yellow, and we'll do the other one in green. Okay, -3. From there, rise 2, run 1. That looks better. Okay, this is how I dropped the pen the other day, so you have to be careful. Oh, I want it to be yellow. Yellow, solid. Oh, that's a box. don't think I hit line. Line. Arrows on both ends. Not bad. A little off. Okay, I'm happy with that. Okay, now, let's graph this one in green.
Sounds like you
Yeah,
do.
line all.
Why?
You colorblind.
I can do blue.
Oh, but seriously.
Can I do like a light blue?
Yeah, yeah. Look at that.
Like that?
Yeah.
Okay.
I'm sorry.
Don't apologize. You can see it?
Yes.
Okay.
Come on, guys.
Okay, now, I gotta rewrite this so that I can use point slope. So it's gonna be y equals 1/2 x plus 3 over 2. Do you agree? Okay. So we have y-intercept 1.5. Rise 1, run 2. Rise, wait, yeah, that's right. Rise 1, run 1, 2. Down 1. Wait, did I do that right? Down 1, run 2. What did I do back? I have to go backwards too. Down 1, back 2. Okay, now, let's go on this line. We did it. Okay, now, let's talk about some of the points. Because it said, verify that, well, it doesn't say verify, but it says show, verify. Show f prime of inverse of x is the reflection of f of x over y equals x. So we have to show if AB is on the yellow line, then BA is on the blue line. Okay? If AB is on the yellow line, then BA is on the blue line. Okay. So let's pick some points. Let's pick 0, -3. Is -3 0 on our line? It is on mine.
Yes. Oh.
-3 0.
I thought you
Cha-ching.
Is it one of the points?
It is
I mean,
It is?
on the blue line.
Oh!
I see now. Don't worry.
Okay, let's pick -1, 1. Oh no, that's 1 -1. 1 -1 is 1 -1 on your, or sorry, -1 1 on your graph. I'm a little off, but I'm not too bad. -1 1. So I do try, like I'm not always really good at it, but I do try to keep the distance between my tick marks the same, but I'm obviously off. So 0 to 1 is not the same distance as 1 to 2, but I do try.
Mine is just a hair off, and my line just kind of goes like this.
Okay, let's try 2 1. 2 1. Let's show 1 2 is on the graph. Ooh, I'm really good right there.
Ooh, yeah. Great job.
Okay, so the last line I want to graph is the the line y equals x. So that's the line y equals x. If we were to fold our paper, so if this was the fold on my paper, these points would definitely fall down there.
Bryce, can you
I
see
just
that?
like.
Well, I know it's dotted, so it's not.
What's wrong with it? Is it the wrong color still?
No, it's dotted.
Yeah, it's dotted. Yeah.
I'm sure.
Okay.
Or Bryson.
If it
And catch
wasn't
Bryson.
dotted, he wouldn't be able to see.
Yeah, it would just disappear, it'd be fine.
Are we always able to use like the tables?
Mm-hmm.
Okay.
Yep.
Like on the test, you're not going to be like, give
Yep.
us-
I don't care how you do it on the test.
So if you just say graph, I could give you a table, I don't have to give you this, technically.
You don't have to graph it the way we did with point slope, you could make a table
If you
instead.
don't say, you use like,
I don't tell you how to graph,
okay.
yeah. Okay, one-to-one functions. One-to-one functions. So this term may seem familiar. I'm not gonna try and close that, I do wanna try and close it, it's better. Okay, to determine if functions are one-to-one, we can do the horizontal line test. We use this test to determine if a function has an inverse function. What's up, Bella?
I only need to do 15, right? Or to the end.
Gives you this one.
Okay. These or no?
These I did in class, so I would just get the answers from somebody.
Okay.
Yeah,
Thank you.
you're welcome. Okay, a function is one-to-one if the function, if its inverse is a function. So in order for a function to be one-to-one, its inverse must also be a function. Okay? In order for a function to be one-to-one, its inverse must also be a function. Okay, so if I have y equals x squared. How do you know quickly, easily, y equals x squared is a function? Passes the vertical line test. Boop, boop, boop. All you do is hit the line, hit the function in one point. Okay, now imagine this is the line y equals x. The dotted line is y equals x. If I flip y equals x squared over this red line, what's it gonna look like?
Sorry, you.
Like Kenny.
Like Kenny.
He said it's gonna be like.
Like Kenny, it's gonna look like this.
It's not.
So it would look like, I'm gonna draw it,
It would not get much.
it would look like that.
It was not.
Right, this point would come over here, this point would come down here, this point comes down here, this point comes down here, this point goes over here. Okay, so this does not pass the vertical line test, correct?
Yes.
Undo, 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 undo. So what we do is we use the horizontal line test to determine if a function is one-to-one. Does it pass the horizontal line test? No, it intersects the function in 2 points, which means, the inverse of y equals x squared is not a function. Okay, now, something I'm pretty sure you've never done before. It's called restricting the domain. Ever hear of this?
No.
Okay. I'm gonna put some of these in your homework tonight.
Thank you.
Restrict the domain of y equals x squared so that its inverse will be a function. Okay. I like to do it visually. What values of x? So restrict. That means I gotta take away some of the domain. What values of x could I erase? What part of the graph could I erase on the board so that when I did the inverse, it would be a function?
X is less than 0.
Yes. In fact, I'm just gonna shade it. If I took all this away, then the inverse will be a function. It will pass the horizontal line test.
I'm just circling. I'm circling, labeling it, take away. X is less than 0.
If I take away x is less than 0, then the inverse of f of x equals x squared is a function. So what would my new domain be? We described what we took away, but what would the actual domain be? So we could say graph y equals x squared. How would I write the domain? For what x values? Yes, we're gonna do both.
Okay. Bracket 0, comma,
Now this says, okay, you're gonna graph this parabola, but only, this is kind of piecewise-ish, right? A little kind of piecewise-ish. So you're graphing a quadratic, but only for certain x values. Okay, what would it look like in, what's the other notation? Inequality form. What would the inequality look like?
X is greater than or equal to 0.
I'm not gonna guarantee, I'm not really sure, I can't remember which way the book does it, so. Just so you know, it could be given to you either way in the book. Name another function, if you can think of one, I'm trying to think of one also, that you would need to restrict the domain on. Absolute value function, yeah. So that its inverse will be a function. No, rational, no, cause it, yeah, yep. Say it again.
Cubic,
Cubic, nope,
cube root,
nope.
What greatest integer?
No, because it would be solid.
Yeah, yep.
Oh crap.
No, wait,
Running out.
greatest integer, wouldn't the lines go from being horizontal to vertical, so there's nothing, so greatest integer will not be 1 to 1,
Oh, yeah.
right? Wouldn't the points go from being horizontal to being vertical when I reflect them over?
Yeah.
Let's try it. Okay, if I reflect over that point, this would stay here, this would come up here. This would stay here, this point would reflect over here, doing that. This point would stay here, this point would reflect over and be right there. So, greatest integer will never be 1 to 1. Yeah, there's nothing you could do to that to make it be 1 to 1. That was a good one, I like that. Okay, anything else? Okay, tonight's homework. Page 99 to 102.
This is home. Yeah.
Numbers 9 through 13, 17, 20, 22, 26, 28, 29 to 32, 39 to 53 odd, 39 to 53 odd, 80 and 81. I could make it the whole
No.
section.
No.
Thank you. Maddie.
No.
She's gonna make it a whole section and
You guys don't need to be here tomorrow, you're fine.
Jacob, I need to get you, I think I have something here that I can give you quickly. And,
Is that okay? Because like, I'm having a really hard time with the, just the, what am I saying, word, saying words, with fractions in general. When it comes to like,
you're just having troubles with domain.
no, fraction.
But what do you mean? Like, what's your trouble?
Like,
I don't understand that.
I still have trouble with like,
Do you want my bag of water?
Oh my gosh, Kirby.
it's just an example, tax.
You're in trouble with adding and subtracting still.
And multiplication.
So I tried that.
Like, with the very start. I'm having like, I'm being completely oblivious right now. I'm still completely oblivious. Even though
I don't have worksheets,
That's when I go to bed.
but
Today, I let him add.
I can give you problems
I have to start waking up at 6:45.
from the book.
I will leave at 5.
Because by the time I park, I walk in. it's 7:20.
Page
So I'm gonna park
A43
I'm
give her my parking permit once I'm working.
through A44. Take your pick.
Well,
And I'll grade them for you if you want. And the answers are in the back still. So if you need help starting them up, whatever.
to Mr.
So I don't have to-
Yes.
I don't have to be the one where they go around and I'm like, oh my gosh, I can't believe it, we don't know when they do the check.